Good morning, everybody. Today is Trig day number 3, compound and double angle identities. Compound identities will be these, or the likes of cosine of A minus B or sine of A plus B. And then your double angles, obviously here, and we will also talk actually about compound for tangent, as well as double angle for tangent as well. So if you're interested, I have the actual proof of the compound for cosine of A minus B, which is cosine A cosine B plus sine A sine B. I use, I believe, the distance formula and a little bit of trig. Well, obviously some trig, but it's interesting. So if you're interested, see that video. I've got that posted in the folder for day number 3. So let's go ahead and get started with finding some other identities from these foundational topics. Okay, so I've got cosine of A minus B equals cosine A cosine B plus sine A sine B. So how would I find cosine of negative x? Well, I already actually know the answer to that. I know cosine is even, so that's going to equal cosine x. So what I'm going to do is I'm going to assign values to A and to B. All right, so if I wrote cosine of negative x as the difference of two angles, A would be 0 and x would be B. So I could write this out as cosine of A, which is 0, cosine of B, which is x, plus sine of 0, sine of x. What you'll notice is that now we just use what we already know, which is that cosine of 0 using the unit circle is 1. So that's 1 cosine x. And the sine of 0 is 0. So that's 0 sine x. So when I add those two together, voila, I get cosine x. Okay, let's develop cosine of x plus y. So this would be cosine of x minus a negative y. And the reason we do that is we want it in this form up here. So A is x and B is negative y. So this would be cosine x cosine negative y plus sine x sine of negative y. Okay. So now we do need to recall, first of all, I do know that cosine of negative x is cosine of x. So cosine of negative y will be cosine y. So this will be cosine y. So it'll be cosine x cosine y. And then I'm going to leave sine x as is, but sine negative y is negative sine y. All right, that's an odd function. So what you'll notice, and you should get used to this, is cosine of A minus B is cosine A cosine B sine A sine B with plus in between. So the minus here equates to a plus there. The plus in cosine of x plus y will be equate to a minus here. So I always think of cosine as the sign inside the parentheses is contradictory or opposite to the sign in the actual expanded form. Okay, so cosine of 2x. This one's interesting. A is going to equal x, and B is also going to equal x because the cosine of 2x is equal to the cosine of x plus x. So that'll be cosine x minus, since we have cosine of x plus x, sine x sine x. Okay, so this is going to be cosine squared x minus sine squared x. Now this is one of the 3 forms of cosine 2x. Another form, I could use the Pythagorean identity cosine squared plus sine squared equals 1 and do some substitutions. I can do that in a separate video if you'd like. Another form is 2 cosine squared x minus 1. And the third form of cosine 2x is 1 minus 2 sine squared x. Okay, so up to this point, we've got each of the following as different forms for those either compound identities or double angle identities. All right, let's look at cosine of pi over 2 minus x. So again, we're going to go back to a minus b. So it looks like a will be pi over 2, and b will equal x. All right, so cosine of pi over 2 minus x will be cosine of pi over 2, which is 0, times cosine of x plus sine of pi over 2 sine of x. All right, now recall that we already said that this was equal to sine of x in our previous lesson. Well, I've got a 0. 0 times cosine makes that go away. And sine of pi over 2 is 1, and 1 times sine x is sine x. So there you have it. On the next slide, I'm going to do all of these for sine, except I'm not going to expand them using the process we just did here. We're just going to talk through them. So let's get to it. Okay, sine of a minus b. If we used similar methods, defining a and b, we'd go 0 and x, blah, blah, blah. It's all good. We would see that this would equal negative sine x. Okay, sine of x plus y. First of all, I guess I failed to go over this, but sine of a minus b is sine of the first cosine of the second angle minus sine of the second angle cosine of the first. So the minus is the same. So sine is the same. Cosine is contradictory. So if we were to use the process of saying, well, a equals x and b equals negative y, what I would end up getting is the same thing, sine of x cosine of y. Now, because this is plus, I would get also a positive sign in between. So that'd be sine of y cosine of x. Okay, double angle for sine is interesting. I'm not going to go through it, but you could expand it saying that a equals x and b equals x and use this formula and expand. But what you'll get is 2 sine x's cosine x's. And there's only one form for the double angle for sine. Okay, and then sine of pi over 2 minus x is cosine of x. All right, let's get into some of the good stuff here with tangent. All right, so tan a plus b. Well, tangent is really sine over cosine. So this is sine of a plus b over cosine of a plus b. All right, now let's expand. Sine of a plus b is sine of a cosine of b plus sine of b cosine of a. All right, I'm going to leave a little space here, and you'll see why in just a second. Cosine of a plus b is cosine a cosine b minus sine a sine b. All right, and so the person that was fooling around with this back in whatever year it was decided, hey, I want to make this simpler. So let's pick one of these 4 items, right? Either sine of a cosine b cosine a cosine b, or sine a sine b. And I'm going to divide by one of them, and maybe it'll make this come out to be a little bit simpler. Well, they chose this one right here. And the reason why is because it simplifies it very nicely. So they divided all terms by cosine a cosine b, and probably tried all 4. But this just made it the simplest. Okay, so when they did that, this is taking me too long. When they did that, they saw this. Well, that turned this term into 1, which we would expect. All right, so it equaled 1. Okay, it turns this term in the bottom right. You'll see that sine a over cosine a is tan a, and sine b over cosine b is tan b. So this is tan a times, I should give it more space, but tan b. Okay, in the numerator, you'll see that cosine b cancels here. That makes tan a. And cosine a cancels here, making tangent of b. So tan of a plus b is tan a plus tan b over 1 minus tan a times tan b. Now, if you were to throw a negative in there, that would just change the signs in between on both numerator and denominator. Okay, so tan 2a. Well, tan 2a ends up being, if you were to look up here, okay, if this is a plus a, this would be tan a plus tan a, which is 2 tan a. So 2 tangent of a. Nothing would change with the 1, but then we would have, instead of tan a times tan b, we would have tan a squared, or tan squared a. So there you have it. That's your identity for tan 2a. Here's your identity for the compound tangent identity. All right, let's get into a couple practice problems and maybe an IB problem straight from one of the old exams, and we'll call it good for day number 3. All right, so let's use what we've done in the last few slides here to look at a couple of examples. So let's look at what we're given here. We're given that the cosine of angle A is 1/3 when A is in quadrant 4. So let's sketch that. The cosine of A, that being angle A, is 1/3. That makes the sine the square root of 8. Okay, so let's look at that. That would be the, let's see, the sine of A is then square root of 8 over 1. We know that the cosine of A is 1/3, and the tangent of A would be, oops, I'm sorry, I messed that up. Give me a second here. The sine of A would be square root of 8 over 3, and the tangent of A would be square root of 8. There we go. Okay, we're going to utilize those in a couple minutes here. Let's look at the second angle. The cosine of B is -3/4 when B is in quadrant 2. Okay, so quadrant 2, we draw ourselves a triangle. Here's angle B. This would be -3 and a +4. That would make the third side 16 minus 9, which would be 7. So this would be the square root of 7. Now, one thing that I did goof up over here is that the sine value would be negative on angle A. All right, so there we go. So now let's look at the sine of A plus B, which we know is the sine of A, cosine of B, plus sine of B, cosine of A. So we're going to have some fractions here to combine. The sine of A, we said, was -√8 over 3. The cosine of A was 1/3. And when we're working with fractions, typically, especially with addition and subtraction, we're looking for common denominators. Now, we won't have to worry about common denominators due to the fact that we're dealing in sine and cosine. So the denominator in both cases will be the same. So the cosine of B is -3/4, and the sine of B is √7/4. So we're going to add these together. That would be +3√8 over 12 plus +7√7 over 12. I'm not seeing a real nice way to make those work. We can't make the radicals have the same internal number, the radicand that is. So I'm going to simplify 3√8 to 6√2 plus √7 over 12. All right, there you have it. That is the sine of A plus B. Now, cosine of A plus B will be cosine A cosine B minus sine of A sine of B. Okay, so same process. Cosine of A. Let's see, cosine of A is 1/3. Cosine of B is -3/4 minus sine of A, which was -√8 over 3. Sine of B is √7 over 4. Okay, let's simplify that one. That would be -3/12 minus, Oh boy, let's go negative, so we'll make that plus root 8 times root 7, which would be 2 root 2 root 7. So 2 root 2, which is root 8, root 7 would be 2 root 14. So we're going to get plus 2 root 14 over 12. Therefore, cosine of A plus B will be, I'll rewrite it in a form that's a little bit more pleasing. Right there. Okay, tan of 2B. So the double angle identity for tangent, just a reminder, is 2 tan x over 1 minus tan squared x. So in this case, x is b. So the tangent of b, let's look here, tan of b, I guess I didn't write those out, would be negative root 7 over 3. Okay, so we're going to do 2 times negative root 7 over 3 over 1 minus negative root 7 over 3 squared. Okay, let's do a little simplifying. That will be negative 2 root 7 over 3 over 1 minus, that will be 7 over 9. Okay, so I squared a negative, which makes it positive. Square negative root 7, I get a positive 7, square 3, get 9. Got it. Okay, so I would get negative 2 root 7 over 3. We'll reduce this in a moment. Over, it looks like 2/9. So instead of dividing by 2/9, I'm going to go ahead and multiply by 9/2. We'll get a nice, nicer answer. Okay, 2's will reduce. Okay, these obviously reduce down here. 9 reduces with 3, giving us a 3. So it looks like tan of 2b is equal to negative 3 root 7. Oops, so that should be 7. Okay, outstanding. Let's go on to a previous test question from years past and show you some strategies along the way. Okay, so here's a previous HL exam problem. It says, given the equation below, represent cosine squared x in terms of A and B. So since I see a multiple angle situation here, specifically a double, I'm going to use the fact that I know cosine of 2 theta equals 2 cosine squared theta minus 1. All right, so I want an expression or an equation for cosine squared. So that's kind of where it's buried. I'm going to find my way to that in just a moment. All right, so let's take A sine 4x and let's write it as A sine of 2x. All right, so this is like 2 theta, right? We'll leave this alone, B sine 2x. You could mess with that, but it wouldn't get you anywhere. Now, it says that this is for x between 0 and pi over 2, which is quadrant 1 angles, and it just basically keeps things simple so that there's not multiple potential values for A and B. All right, so we know that sine of 2x is equal to, based on our identities, 2 sine x cosine x. So that means sine of 2x's would be 2, we'll bring the A along with it, sine x, which in this case is 2x, cosine 2x, plus b sine of 2x equal to 0. Okay, just loaded right here is what we're looking for, right? I see cosine 2x there. I'm going to then rewrite this as 2 cosine squared x minus 1. All right, and that's where typically every problem has its key hidden somewhere within the problem involving some kind of identity or something like that. So what I want to do is I want to isolate cosine squared. So I'm going to subtract b sine 2x from both sides. That gives me 2a sine 2x times 2 cosine squared x minus 1 is equal to negative b sine 2x. All right, now, next thing I'm going to do is I'm going to divide both sides by 2a sine 2x. The sine 2x's will reduce. Okay, so I'd get 2 cosine squared x minus 1. On the right side, again, sine 2x's reduce. I will get negative b over 2a. All right, don't be fooled into thinking there's something quadratic formula going on here. It just happens to be very similar. So I'm going to add 1 and divide by 2 here in a moment. So let's add 1 and divide by 2 like I just said. That gives me cosine squared x is equal to negative b over 2a plus 1 divided by 2, or multiplied by a half. We can make this a little bit more pleasing to look at. This would be, although I believe this would be an acceptable form, it's just not very elegant. So I'm going to rewrite this as 2a minus b over 2a. Now what did I do to get that? Well, what I did was I turned this 1 into a 2a over 2a, and then I get common denominator, combine them. So I can finish this off. So cosine squared x, this is going to be pretty nice looking, will be 2a minus b over 4a. There you have it. But like I said, likely IB would accept any one of these 3 equations. All right, guys, that's day number 3. Let me know if you got questions. See you in the next video.